Oh, it's a grid. Long walk, a map of hiking trails, path, forest, and slopes. Currently on a single path on top row, your goal is to reach the bottom row because of all the mist and waterfalls. So I see never step. Uh, what's the longest hike you can take uh, without returning to the same longest route? Interesting. Okay, so let's start by reading the grid. Done. Now, okay, we have our start position, which is marked with, okay, start position is the top row. Okay, so we start at row 0, column 1, and we are trying to get to the end, and we're trying to find the longest route that does not, okay, so how do we do that? Let's, okay, so obviously we have a graph. Uh, uh, it's NP hard. Great. Uh, da, da, shown to reduction. Newtonian. Okay, so longest path is NP hard. So there's not an easy way to do this. We just need to look for all the paths, and there's not anything to do with the slopes. The slopes are, we're ignoring them right now. Okay, so, okay. So I need to do the following. Okay, so let's put the row column is open. And by row column, I mean 0, 1 is an open. While open, let's do this. My closed, my, actually, let's use the easy coordinate system. My O equals shift of open. Okay, now I need dollar closed of O plus plus. Okay, while my dollar n in one, sorry, grid one of O, orthogonal neighbors of that, we have now my row column. Actually, no, it's going to be row column and value because that's how one works, equals the neighbor. Okay. Next, if value equals hashtag, because hashtag is a wall and we can't get there. Next, if hashtag value equals hashtag, uh, and then we need to, okay, we need to find a path. So I need to, I'm finding the shortest path. I need the longest path. So again, I'm for every closed, I need to find a longer path. How do I do that? Do I need to do DFS? I need to do DFS. Don't show no, yeah. Never mind. I'm gonna do DFS. I need to do DFS and then I'm finding all the possible paths. And then once I reach the end, okay. Okay, so uh wait. I mean I still need a set of closed. It's just okay, I'm gonna think about this. Okay, now I need to keep iterating on that. So usually I'll just add that to open. The thing is I want the longest path. So if I find a longer path, I need to take care of it. So how does that work? So I need to close. actually, so open will be 0, 1, and we reach that with the distance 0. My O, my, my O and D equals AA. Okay, now closed of O equals D. That means that's actually, I need to make sure, okay, unless closed of O and greater than D. That means I already have a longer path. So no, that I don't need to do that. I mean, that means I found a path through in distance D. Now I need to add, this will be shortest path again. I need to think about this. Shoot. But let's, meanwhile, also write the code while I'm thinking. D plus 1 is the distance we will find there. And then, actually, let's mark the beginning as 1 just to make it a little easier for us. Okay, and then D plus 1, that marks it as, yeah, as we found the path of length D plus 1. And then, also if it's end, that will find the shortest path. I want the longest path. How do we do this? I think. So to find the longest path, I need to uh, I need to find all the places. For every place, I need to find the longest way I can get there. So for uh, so beginning, it must be that way, but then I need to figure out if there is a longer way to do this. So I need okay, so I need to say I have a better way. So okay, it's not closed is not okay best or something like that. So but also I need my P, that's like the path I've been taking because I can't go back to the path I've been. So, okay, now, unless next if P of V, that means P of V means we already been on this in this path, and then that's not good. Actually, so how do I get the P's? The P's should be uh, because now we need to DFS, not BFS. That's the main concern we have, right? So instead of while open, sub scan, uh, and then okay. So and now I need to do scan. So I need POND, right? Okay, POND, and then I need to mark P as follows. And D if uh, if either there is none of them or best of O is less than what we found. Okay, now I need to call scan with declone of P, make a copy of the P so we don't accidentally actually no, don't clone it. Send it the same P, the same, the O is RC and the D is D plus 1. And then I need to reduce, so delete P of O. So, and now I'm gonna scan from empty start. The open is 0, 1, and the distance is 1, but I'll need to make it 0. So now that will give us, yeah, and then this will give us thing, and now I need, that should, okay, that should work, right? That will give us the worst path, and now I need to just return out best of grid calls, sorry, rows dot comma dot grid calls -1. Okay, let's see. Syntax error at line 23. Line 23, that's, no, line 34. Line 34, 4 I meant, not while. I've changed my mind here. Deep recursion. Okay, that is running, but it's slow. I don't know if it's not gonna finish, so let's run it on the simple input. Okay. Let's okay, something is definitely wrong here, because it needs to be, if it's P, then we don't do it, right? Okay, why is this not working? Grid is one of that. Next, if P of so and so. Actually, okay, we don't need this. We can use P like that, P like that, P like that. Don't P and delete P. Right? Yes. Hash, etc., etc. Is okay. Where did? Oh, yes. No, still doing something weird. Okay, why? Why is it going? OD. P of O. Okay, so we've said we've seen that. Now scan RC D plus 1. Next, if P of V. So, not V, P of RC. Oops. 2323 isn't numeric in subtraction. Line 47. Yes, I meant obviously that. Uninitialized value. So, what we're saying is you never found an answer, which is weird because, okay, grid, oh, rows -1, calls -2. Oops, yes, yes, yes. It's rows -1, columns -2. 155. The correct is 94. So that's definitely not the right path. 154, which is definitely wrong. Let's also okay. Let's do the following. When we do so, what is 2221? So if O equals 2221, grid dot print keys of P. Okay, and why is this? not a possible path. Actually, it looks very similar to the path that this they found, except it goes this way. Oh, downhill. Oh, goes to, okay. Slopes are possibly quite icy. If you step on a slope tile, your next step must be downhill. The direction of, oh, so these are directionals. Oops, I didn't realize that. So that means that, okay. That means these are directionals. That's annoying. Okay. So let's do this. Uh, Previous and next are like that, and the value, right? Okay. So my px py call split by comma previous my nx ny call split by comma of next. Now, next if return one if b equals dot. Okay, now my dx dy is nx minus px ny minus py. Now I need to check dx dy if it is allowable. So yeah, I need to check. So HH equals, okay, now less than means that you cannot be going horizontally to the right, which is 0, 1. Yes. Greater than means you cannot be going 0, minus 1. Caret means you cannot be going 0, 1, 0. And V means you cannot be going minus 1, 0. Okay, and now return if HH of V is not equal to dx dy. I believe that's the thing we wanted to do. 154 still didn't. Oh, yes, I need to now. Next, unless check there of previous is O, next is RC. Okay, use of an initialized value and hash element. That's interesting. That's concerning. Say AH of V. Uh, Wait, okay. Why is this? I mean, there's something silly. Uh, V is, oh, check there. Okay, yes. I didn't pass the V here. Yes, that would cause it. Yep. 94, that's the correct answer. I should remove the bug prints. Okay, where is the debug print? That's correct answer. Part 2. Ground to slippery, to all slopes of normal path, you still want to make sure. Okay, so that's what we did before. That's exactly what we did before. 154, yeah, that's. I still want to make sure. Yeah, and the problem is this is taking too long. but longest path in general is NP hard. So we need to think of a better way to do this. Because, yeah, doing a basic DFS, can we memorize this? I mean, what I'm trying to say is I want to find, I'm keeping, yeah, I'm doing the same path over and over again. So, huh, that's interesting. And thing is, it's not even finding a path. Well, no, this is. Uh, hmm, okay, okay. That's So how do we? Basically, if we didn't find a better path, then we don't need to change to keep looking, right? Because we already. Yeah. So basically, if let me do it like this. I think this should work. And uh, if it okay, now let's try run it on the simple input first. 154, still the correct answer? No, that's interesting. This is not correct, even though, huh, okay. So what is the mistake here? I mean, we did find 154 here, which was the correct answer. Uh, let's, okay, let's just mark this in a, okay, okay, O is end, red print keys P. Okay, so what I'm trying to say is if you are not, if your path you found is not longer, oh, but you might be not using a area, so it's still, you still need to look at that. Okay, okay, so yeah, you can't just return here. You need to do a little bit more work here. See, it's already finding longer and longer distances. 58, 54, okay, yeah, I found 58, 86. Just, oh, not the right answer. I was like, that's not lucky if it, okay. So yeah, that's the problem. The problem is, yes, I didn't find a longer path, but I may have found a path that is, it doesn't use area, it doesn't block something. So how do I deal with this with this edge case? Uh, hmm. So definitely, if the path I found uses more stuff, then I can definitely say. So, you know, if it uses more stuff than the best I found, then I'm definitely, that definitely won't work. clone. And now basically I can do following. I'm going to look at, yeah, keys. Okay, yeah, now, okay, so that's, cause, okay, no, for my, uh, P, so I need to check if all the ones that were seen before are also, uh, if this path that I found has all the ones that were before, so all the ones that were before are in this path, then I know it's worse. Uh, but that can't be because then it would be shorter, and that's, yeah, that doesn't help. So that doesn't help. And we know that longest path is thing is that there is a maze here. So we can do some shortcuts if we look at the input. Let's add a heuristic. I'm very confused here, but okay. Uh, sort. I'm gonna sort it by uh, actually I want the one with the least Manhattan distance. Yes. Okay. So now I need, let's read by comma of Rx. 5886. Okay. Oh, still the best we found. And let's see now, what is this path? If we enter here, like we need to go to the right here instead of down because that would be the wrong answer. Uh, wait, we can do the search from both sides approach. Uh, basically choose a middle point. Yeah, this maze is very carefully designed. Like this here, you can go through here, you can go through there. No, and just using a heuristic won't help. I can probably do some manual work here and do it like that. But otherwise, I'm not going to. Yeah, this is not going to help. Uh, Otherwise. Mhm. Let's see if I can do. I don't think it is. I'm not sure. So what I'm saying is, how do we do this? I'm not sure. So what I'm trying to say is add some heuristics. Row 13, um, column 5, go right, which is 0, 1. Row 33, column 0, 1, 2, 3, 4, 5, go right. Uh, Row 57, column 0, 1, 2, 3, 4, 5, 6, 7, 7, 7, go right. Go right. That's enough right here. So, okay. And what I'm trying to say is now basically, oh, actually, yeah, let's just prefer to go to there. Prefer to go to there. Prefer to go to there. Okay, which means if it is, then assume it is. If heuristic of x and 0. It's the best thing to try, okay? 5822. 6022, it's already better. Let's try this one. No, it's probably not good because it's already much longer. Yeah, let me. This is not a solution. I'm 0, 1, 2, 3, 4, 5. Eh, mhm. Which way are you going here? In here in this path? Yeah, this is okay. Let's say prefer. Oh, that's a problem, right? Because if you get in here, you can't get out. Well, you can get out there. Is this thing doable? Maybe. Let's try 6022. Just this higher. Again, the problem, we're using DFS, which is not the fastest solution. Mhm. Don't understand uh what can we do to make this any better? Guess as a heuristic, we want to go. I mean, if we can split it into choke points, then it's oh, whoa, 6150. This is not gonna work. Yeah, I'm getting this. I don't know what to do about it because this is again there are a few. So there is a standard path and there are a few essentially long cuts. So what if we oh, 6182. What did they even change? Yeah, I went through there. Okay. So what I'm thinking, if there's a single path, we can shorten this. So basically, for every, let's try to shorten any case that there is a single path to make that a lot faster. And meanwhile, 6182, we can try that one. Oh, 2 minutes. Okay, so let's try this. So we want to essentially find, so I'm going to go over the entire graph, grid, iterate, and let's, the sparse one, it's the same thing, iterate, sub row column value. Okay, yep. My RCV equals that. Okay, and now what I'm trying to do is return if B is a hash. We don't care about that. Now I need a grid one of RC, and I need grep ones where of 1 does not equal hash. Okay, now I'm trying to say if it's equal 1, then I can skip there. And okay, while n equals 1, actually, okay, my nrnc equals rc, just so I can let's nrnc equal, wait, oh, okay, now okay, rc, one of chord, chord equals n of 0, and let's and we try again. Now, okay, we do that until and it's not 1, and then okay, and then oh wait, I, okay, so it's not the previous one, it's not that, and now I can okay, shortcut of row column equals chord. Let's try to submit this just in case it's right. Yeah, it's probably not. Okay, shortcut equals chord, out shortcut. Let's see how this looks. If chord not equals RC. Basically, I'm saying, wait, no, this is not, can't be there because, frick, that won't work. That won't work. I need to know where I'm coming from and where I'm going to. Okay. Because there is no prev. Uh, so, okay, and then basically I need to pick one. I mean, this sounds good, but it's not what I'm trying to do. So the shortcut must start when there is a place with, so most of the spaces have exactly 2. I need a place that has exactly 3 or more, and its neighbor has, okay, so let's call this y. So because y is next, return if y is less than 3. Only ones that have 3 or more neighbors I care about here. Now I say, okay, prev is chord for each y, and chord is y. Okay, do this while n equals 1. Okay, so previous and chord equals chord and y. Now I find the neighbors, go to the next coordinate while n equals y. And then if I found this, if in shortcut of y, when you enter y, you must go to chord. Wait, no, not chord, but prev. If you enter y, you must go to prev. No, okay. Unless prev is y, and then that's not, because, wait, prev can't be y, because prev is chord. No. Okay. Yeah, prev is chord. Chord is n of 0. And keep going. Shortcut is that, okay? Let's try this. Let's keep running just in case. Okay, at line 56, I have n, yes, and I did not indeed declare it. Okay, that's not ending, so that's bad. Let's add some debugging here. Oh, why is Prev. Wait, Prev and chord shouldn't be arrays. Why? How did they become arrays? No, I meant that why. How did Prev? That's 0 of 0 again. Okay, let's grid dot print keys shortcut. Okay, what about values shortcut? Okay, okay. Now let's do the following. Uh, Also, oh, I need the distance, right? That's important. So let's keep this here. Distance. So uh, let's just. I want to take a look at this to see. Oh, that's a very nice shortcut. Mm-hmm. Okay. Yeah, these are very nice shortcuts. Mm, okay. Okay, shortcut. Now let's put add to the shortcut. I'm already over almost an hour. Okay, so prev and scalar path. That's the length of the path from the start to the. How's my? Yeah. So just I need to make sure I don't have any off by ones. The easiest way is to run it on the simple thing. So okay, and that's the path in. Okay, and now I need to do the following. When if I encounter a shortcut, I need to adjust so immediately. So that's this, okay? And then shortcut, I need to shortcut of RC. If there is a shortcut, then okay, then RC equals RC and extra equal shortcut of RC. And I believe I need that +1 then. Or the easiest way is to just put prev there, basically. Put forward there. Okay. Okay. What is wrong here? Line 59, uninitialized chord. Line 59. And why does it end with -1? Wait, try to see. Yeah, okay. What? How is RC nothing? How is RC nothing? How is prev nothing? Something is weird here. Undef. 4-3 leads to undef. Why? Let's look at the input again. Row 1, 2, 3, 4, column 1, 2, 3. Here, this is. There should be only 2 neighbors. Why did you even add this? Well, why? Just in case it's something silly like that. No, it's not. Yeah, another one. Oh, a bunch of them return undef. That shouldn't be. 2019 also returned undef. Why? Undef as prev. Why is prev not defined? Prev. Okay. Hmm. Okay, when is chord not? Okay, the chord is always defined here. Oh, what if there's no neighbor? What if there's no neighbor? If there's no neighbor, yeah, then you that means you're stuck, right? That okay. Chord. I'll just ignore that for one. If it's a dead end, alright, and it does okay. Then you have to go to 15.3, but that's not correct. Okay, so let's make the shortcut more clear. It's not just Y, okay? It's going to be of R, C, Y. So row column that you tried to do. And now I only checked shortcut of O, R, C. Line 96. No, it's still okay. Mhm. Okay, yeah. 15.3, and then okay. Oh, I know why. Because you need to add. Yeah, you need to add to the shortcut the one before that, so you know. Hmm. Hmm. Wait, no. Scalar path. Okay, okay. And now you need to. Okay, let's. Is there a better way to do this? Shouldn't the shortcut exist in both directions? Oh wait, isn't this all we need to do? 160, which is not the correct answer, which was 154, and that's probably because of our, yeah, I was not sure about shortcuts. I think this will solve the problem. Yes. Okay. Wait, where is the... Oh, that's the... So I know there's the precursion. Why is it still taking forever? Let me just rerun this. So the shortcuts should help immensely, but it goes much less stuff to look at. Okay, let's... Shortcuts to null are also good. Oh, yeah, that's a problem. If you've reached end, that's why you're not having any neighbors, then last. Otherwise, wait, what? Oh, it goes to Prev. Why is this? I don't like this. Why is it getting? Oh, first of all, let me. Sure, yeah, still. But why isn't it using this? If Prev equals end, then it needs to put shortcut to RXY equals end and. Right, so. Mhm. So why? How is this? I'm not sure why is it doing this. Why am I not getting shortcuts to end? Why isn't there a shortcut to end? Why? Oh, row column Y. Yeah, why isn't it setting this? Oh, unless prev equals Y. Why is prev equal Y? Prev shouldn't equal Y, right? right? Because y is a completely different thing. So why is this not happening? End of prev is 21 to 8. Yeah, prev is not equal y. Okay, and then it should exit this loop. Okay, why isn't this happening? Mhm. I'm not sure. Okay, now it's doing it. I'm not sure why it didn't happen before, but now it's doing it. Okay. Mhm. Now it's using shortcuts. Why is it still taking forever? I'm not sure. Again, so now it's still now it should a lot better, right? So like this you can't do because it goes back to when you've already seen in this path. So it's like, why is this still taking forever? What am I missing? I mean, it's still not even fast as the one without shortcut. 6102, and we have 6182. I mean, it's definitely using shortcuts everywhere. There's a whole bunch of decisions, so all of these corners need to have a whole bunch of options. And there is no efficient algorithm. Uh, let's see how badly I did in part one while we're waiting. 596. Wow. 38 minutes, 7 minutes. What am I missing? 809. Oh, I'm not even getting top 1000. What am I missing here? I implemented shortcuts. 6134 is not even. 6182 is the best I have so far, and it's not correct, right? Yeah. It's not even reached that level. Shouldn't take this long. I don't understand. Like you take the thing, you look at the neighbors. For each neighbor, you look at the shortcut. Are there more dead ends? Are there? Well, one thing I can do is prune dead ends. Wait, let me try something silly a little bit. Uh, there's no reason why going backwards will be faster. Yeah, there's no real reason. One thirty, and this is 6182. No reason why going backwards would be any better. 6234, that's already better than any number we got so far. 6334. Holy shit. No, it's on clock. So, yeah. Okay, so let's stop this one. 6390, better. It's the same shortcuts, right? The shortcuts don't care where you're 65, 46. Even better.